Hello guys and welcome back to the channel. Today I'm going to show you real fast how I made this set of stairs. It's made entirely with nodes. So you can see we've got a bunch of nodes here and all these net that goes around and comes out with this set of stairs. And I'm going to show you real fast how to manipulate it. So we have our modifier property panel here on the right, and you can see all these parameters that you can change and customize your set of stairs. So no more modeling stairs for you architects are there. This is the only stair you're gonna need. So let's start. I hope I guessed right these naming of these parameters, since English, as you can probably hear and notice, is not my mother language, but I think we'll manage to understand each other. So let's start with elevation. This is pretty self-explanatory. It's practically the height of the stair. So it starts from 0 to, let's just use this cube. As you can see, if I press N to see my side panel, this is the standard default Blender cube 2x2x2, so 2 meters. So if I set this parameter to 2, this elevation, it's going to start from 0 and it's going to come right here at the 2-meter height. Then what we've got next, then just get rid of this, and what we've got next, we got width of the stair. Okay, so you can manipulate the width of the stair. So if you set 2, should be just right. As you can see, it's working fine. Let's, I don't know, maybe put it 1.2 meters like this. Then what we've got going and rise. So if I understood correctly, going is practically the size of the step in this direction, and rise is the height of one step. So it's practically this little thing, you know. So going, it's if we increase it, you can see that the height of the stair remains the same, 2 meters, but it takes a lot more space in that direction. Okay, then we have the rise. So if our rise, the height of one step is this big, then you only need 5 steps. Simple as that. Let's just put the, I don't know, default values, like going 0.3 and rise, let's set 0.50, so 15 centimeters. And let's just move this cube so we can see a bit better. GX on this. Okay, and now we have our normal looking stairs. Let's go back, and now what we have here, we have thread thickness. Let's just increase this to 0.3. So okay, so the thread is this little dimension here. So this thickness, you can increase it, or the nosing is how much this thread is going over our riser. So if nosing is now 0, so it doesn't go over it, but if we increase it, we can have our 1 centimeter nosing, or maybe 2, like this. Okay, and then if we, for example, just get rid of the construction, we have our riser, which is this little plate here, and this riser, we can get rid of it with this. So 0, we have it. 1, we have it. 0, we don't have it. This is something that you can also use maybe against the wall, and you can also have this type of stair. Okay, so riser, yes, no. And if we choose to leave it, then we can adjust its thickness with this little parameter. Okay, and now is the fun part. And the fun part is the number of beams. So these are like, let's just let's just sorry. So beam width. So this is our beam that can have its width. So if you set it the same size as the width of the stair, 1.3, you'll have your concrete stair, monolithic, the usual thing, let's call it. Or you can set it to much lower value like this and have, I don't know, something like this, and then maybe remove the riser. You can have something like this. You can even lower the width. And the cool thing about this, and now you can add more beams, up to 5. So 1, 2, 1, 2, let's look it from this side. 1, 2, 3, 4, 5. How cool is this? And of course, you can set the width like this, and you can set the beam thickness. This is the size of the beam from this point to this, and you can increase it, decrease it, whatever you will. And in the end, the last thing is the materials. So you can set, let's put the riser back. You can set the material, the beam material. You can set the red material, and you can set the riser material like this. Of course, the materials are something I had inside this scene. The material, whichever material you'll have in your scene will appear in this list, obviously. Okay, so this file is going to be available for you to download on Gumroad. I'm going to leave a link in the description down below, and you can check it out for yourself. And since I'm not going to explain every little thing I did, I'm just going to start and like walk you through the most important parts. And since this video is already too damn long, I'm pretty sure none of you are actually gonna watch it till the end. So I'm just gonna start like talking a bit about what I did and how I did it, and then you can go download the file and check it out for yourself if there's something you didn't understand. And of course, in the comments, you can always ask me whatever it's not clear. So let's start with the beginning. So the first thing is our group input node. So this is the node that's actually showing all of this on the outside. So whatever is here is going to show in this. So for example, if I wanted to set this here, it's going to appear another Z, and I can, but we don't want to do that. So let's bring it back. Hopefully we didn't mess up the whole thing. Looks like we didn't. Okay. First things first. This node here is actually a group. So it's actually a group of nodes, and to go inside it, just like you would go in edit mode, you can press tab, and here is what's going on here. So why I did this group node, because this is actually a value. These two I'm going to use a lot, and I don't want to do every single time this operation. So I just chose to create a group node, and this is what I will use throughout our node tree. And what is this, the true rise? So I told you before that I'm setting our rise here. So we have a rise of 15 centimeters, and we have our elevation, that's 2 meters. And if you do the math, 2 divided by 0.15 is actually 13.33. And 13.33 is not actually a number that you can use putting the pieces of steps. You know, you need an exact number, an integer. So you need to round that number. And so what I did in this group node, let's go inside it. We have only two types, one type of node actually. It's the math node. This is all math nodes. Add search math node. That just lets you have all these different operations, math operations that allows you to do these things that I did. So I'm going to show you what I did actually. So first math node is divide the elevation, which is this number here, with the rise that we've set. And that's actually the number that came out, is that 13.33, as you can see. And then another math node, but this time we chose the round, which rounds the value to the nearest integer. And that integer is obviously 13. Am I right? Yes. So 13 is now the value that we're going to use in our next node. And we're going to use our elevation now, divided by the rounded number of steps that we need to get the actual rise that we're going to need. So we divided our 2 meters with 13, and the value is 0.153846. So actually our true rise, that's how I call this value, true rise, it's the rise from here to here to be able to get to 2 meters exactly. Because if I was placing these rise values at 15 exactly centimeters, 0.15 meters, I wouldn't be able to reach 2 meters exactly. So this is our true rise, and we're going to need it a lot with the other formulas in our node tree. And then of course this value here is the count, is the number of steps that we need, and it also needs to be an integer. It needs to be 13 steps and not 13 and a half steps. How can you have half step? Anyway, so these two values are what actually comes out of this node. So true rise is this float number and this count, which is 13. Perfect. And another cool tip that I'm going to show you now for this group input thing. So a lot of people, when making these kind of node tree, they use this group input and all these parameters here, and they connect it all the way everywhere along this this node tree, and what you have is a mess. The cool thing about this node is that you can actually duplicate it with Shift D, and then you can place it wherever you want. So if I place it here, and you can notice that, for example, if I this going that is plugged into our X value here, if I plug it from here to here, nothing changes. So it's the same thing. So this is actually a very cool thing, and I use it all the time. But then again, with this kind of node, when you have this much parameters, and this node is huge and it takes a lot of space. But there is another cool tip for you, and it's actually with this node selected, you just press Control H. Oops, sorry. What did I do? I have no idea. Did I mess up? No, I didn't. So Control H. And what it does, it hides all the parameters that are not used, that are not connected to anything. So in this case, we only have elevation going and rise. Perfect. Okay. And then obviously gonna notice this node a lot everywhere we go, and so on. Okay, let's finally do something. Oh my god, it's already 15 minutes of this video. It's gonna take a lot of time. Okay. So let's start with the start. So how are we gonna do what we want to do? And we're gonna use our mesh line node. So let's see, we're gonna just press Shift Alt, left click, and then we're gonna create a connection from the geometry node that is selected to the output group node. So every time you select this and then press this, it sends the signal to the output, so you can practically see what are you doing. So this is the last node, and you want to see what's coming out of this node. Shift Alt click, and this is what's coming out of this node. So let's go back to the start. So mesh line. Mesh line, it's just a simple line. And what it does actually, let's just disconnect this and let's disconnect this. So this is a line that's starting somewhere, and this is the values, the vector values where the line starts, and this is actually 0.000. If I move these values, you can see that the start point is changing. So let's put it back to 0, and then it adds vertices. And how much vertices does it add? This is the number of vertices it adds. So, and where does it put them? It puts them exactly where you tell him to put it. So if I want to put it like 0, 0, 1, my next vertex is going to be placed on 0, 0, 1 point from the start. And if I add another vertex, it's going to just add the same amount we have here over the first vertex. So let's put like 1 here also. And you can see that now we have 3 vertices, and these three vertices are this one's here, this one's here, and this one here. And the values we are moving is these, this on the x-axis one and on the z-axis one, and another one on the x-axis one and on the z-axis one. Okay, I think that's clear. And so what do we want? We want these vertices to be placement of our steps. So we need to start from the 0, and then we need to add one, you've guessed it. So going, rise, going, rise, going, rise. And we need to place these vertices on this here. And of course, we already know how many steps we need because we have it here. Our count value needs to go into here. So now this is 13 steps. As you can see, our line grew considerably, but we need to place it a bit in a different position, these vertices. So we need to change the values here, but first we need our combine XYZ node. This is actually combine XYZ node. Combine XYZ, it looks like this. This is the same node. I just renamed it with F2 and I called it end. And this is actually not an end, this is the offset. So let's just correct this. Okay, perfect. And then we need to connect this to this. Actually, it should be like this, but sometimes I do this because it's more, I don't know, manageable. And then we need to, our X value, which is this value here, needs to be the going, and our Z value needs to be our true rise. So let's connect these that are already connected, and we have all our little dots placed in, not dots, vertices placed in the right position. Okay, so this mesh line here is practically what I use to build the whole thing. This is the most important part. You need to get this right, and everything else is going to be simple as nothing, as simple as whatever. Okay, let's move on. So I use this, as you can see, for 3 other things. Let's start with our thread, or thread, I don't know, correct me. And so what's going on? I send this line to this point scale node, and then point translate node, and then point instance node. Let's go into our point instance node to see what actually is happening here. And let's just mute these point scale and point translate. And we are muting with our M key on the keyboard. And what's going on here? So we have our point instance. Point instance node places an object to a vertex. So it's placing this object here, and I'm going to show you what it is in just a second. It places this object, this step object, to every vertex we have on this line. And what's let's just show you this step object. It's hidden, so this is here. Let's select it. So this is actually our step object. It's just a cube, 1 by 1 by 1, 1 by 1 by 1. Let's just see, 1 by 1 by 1, with its origin point set here. So in the middle, on the y-axis, and up on the z-axis. And this is our step, and we're going to use it to create our thread and our risers. So let's hide it again because we don't need it. And let's go back. So, but this point instance we need to scale these to set them to the correct scale, you know. So how do we do that? We do it with our point scale node. So let's unmute this and see what have I done. So our geometry comes in here, it comes out here, and this is the factor. So if we unplug it, we can see that we can manipulate the scale individually on all three axes, but we need to set the scale individually, and here we have only one handle, and it needs to be connected again with the XYZ combine node to 3 handles like this. And now you can change individually all these values, and you've guessed it. So the X is this value here, the X is this value here. So like this is the X, right? And what does the X do? Let's just start with the simple one. So Y is this value, right? This value. It's actually the width of the stairs, and the width of the stairs is right here. So just connect it to the Y, and then the Z is actually this. This is actually the Z. So the Z is the thread thickness, of course. And let's go back to the X, and X is a bit more complicated. This is the X, and the X needs to be, let's put back also our rise, just to show you one thing, So this is our X value, and it needs to be our riser, sorry, our thread, right? So this is our thread. It needs to have our nosing, and it needs to have our riser thickness also. Here, this, and this little nosing thing. And we're going to use a bunch of math nodes to get that value on the X. So we have our riser thickness, and going, it's added, and then we need to add also to this the nosing, and we need to multiply it with the -1 to go into the point translate, which is the node that actually moves, because if we mute this node, we're gonna move our thread here, and it needs to go back. It needs to go forward. But as you can see, our X value is positive in this direction, so we need to move it in the other direction. To have the negative value, we need to multiply the riser thickness to -1. Okay, I hope this was a bit technical, but hopefully you got it. And that is practically it. The next thing, this is our thread, and our thread is final, and we just need to pass it through a material assign node to be able to connect this material socket to the thread material, and then we can select it from here. Okay, perfect. And this is the thread, and off we go. Then the riser, I'm not gonna go into detail with this one because practically it's the same thing. So we took the same mesh line, remember the mesh line, this one, we took that, and we did the same thing. We just, this is the point scale and point instance, which shows the same step object, and then we moved it a bit here and there to get the riser right, and the material assigned at the end with all the riser. Another thing here, I used this transform, which is actually also hidden. This is the look of a transform node that lets you transform your geometry in all the directions, and it's very cool to duplicate. It's very cool to use it to duplicate geometry. But anyway, I use this scale node here and to practically remove this geometry if I don't want it. So what did I do? So I have my risers here, you know, I have my risers here, and what if I don't want them? How can I get rid of these? I can actually change the scale to 0, because everything scaled with 0 practically disappears and becomes a point. So I connected this to one math node, and I set the multiply as an operation, and I chose 1 as our initial value. So and then I connected this to our group input node and to this riser yes no. So yes no, it's just it's practically two values are possible. So 0 sends a 0 value here, and everything multiplied with 0 comes out 0. So we set the scale to 0, and these risers disappear. And the other option is 1, and then it sends out 1. It gets multiplied by 1, and the scale is 1, and nothing practically changes. So that's kind of way to hide something, and that's what I did to hide our riser. Okay, that's enough with the riser, but I want to show you another thing. I want to show you, if you into our geometry node editor here and press N in this group side panel, here we have all our parameters that you set here. And the cool thing about this, for example, let's see this riser yes no, you can set the type. So integer is a whole number, while float, for example, is a decimal number. So we need an integer because we don't want 0.2, 0.3, 0.23 or stuff like that. We just want 0, 1. So integer, and then you can set the default. Okay, so when you first plug in this node, it's going to be this value, and then you can set the minimum and maximum. So if you set 0 or as a minimum and 1 as maximum, these are the only two values that are going to appear. Another cool thing that we could have done is set this to Boolean. So Boolean is true or false, but it comes out as true or false, and I don't know actually how to use true or false to set the scale. So 1 or 0 for me, it was simpler. Okay, I need to put back all these things that there were here before, but that's no problem. And this is, and you can set all these types to all of these parameters. So a material is obviously going to be a material. You cannot set a texture. Okay, but anyway, So N for side panel. And riser goes out and it joins with all other geometry. Now let's go to set our beams. So beams are incredibly complicated, but I'm gonna teach you something cool with them. So beams, we took our line, our start line, this one, it's always this line, and we added 4 more lines. Connected them to transform node, 4 transform nodes, and the original one. So we have 5 lines, each of them moved by 1, then 2, then 3, then 4 meters on the Y. So let's see, this one is moved 1 meter, then this one is moved 2 meters, this one is moved 3, and this one is 4. And then if we join them all together here with the joint geometry, we have 5 lines. So we have 5 lines all separated by 1 meter, and this is practically our points for our beams. So we need, how do we scale these lines in respect to what's going to happen with the width of the stairs and all that stuff? So we need to place them, and we also want to have some of them hidden if we don't want 5 beams, as you can see. So how did I do this? And now comes the cool thing, the attributes. And here is where we're gonna need our spreadsheet here on the side. Let's just hide this. This is not very useful. So these are the spreadsheets of our attributes, and it actually shows these are the vertices that we need here. So this number here, as you can see, we have 64 vertices. That's actually should be our five lines multiplied by the number of vertices of each one. So 13, probably it was 13, I think. So 13 times 5, it should be, I don't know, maybe it should be let's just try again, go back here. What happens if we have like this? Okay, 12. Yeah, because the first vertex is labeled as 0. So actually there are 65 vertices from this point on. So 64 and 0. And these are their coordinates on the X, Y, and Z axes. So how do we hide some of them if we don't need them? And we're going to use attributes. So first we're going to separate our X, Y, Z attribute. So this is a node, it's called attribute separate. To find this node, Shift A, search, and here it is, separate. Sorry, that was combined, but anyway. And then what we're going to do, we're going to practically, this does nothing to geometry, it just creates attributes. So what we've done, we've taken our vector position, which is this one here, this attribute position type vector attribute. Okay, this is an attribute and its position, and this one, and we're going to separate our X, Y, Z. So I named this attributes X, Y, Z, but you can actually, I don't know, maybe let's rename them just for the sake of it, so that we don't make a mess. So it's something that you created. Okay, so now let's see what goes on. Again, Shift Alt right click, and now these attributes are created, and all these and this point, each of these vertices from now on gets sent out with this attribute, but also with these, and it's obviously copying the values here to here. Okay, and then we want to create another attribute. And how to create another attribute? We just add an attribute fill node and just set the type of the, because if we set float, then it can be decimal number, but we need just a Boolean. So we're going to set a Boolean because we want to have a yes/no situation. Let's just go to see what sends out with this. As you can see, it's creating a bool that doesn't know what to do with it because we didn't tell him what to do with it. So it just comes out as 0.000 because we set it as a float. But if we set it as a Boolean, we're going to have like this checkbox, which means if it's either true or not true. That's the Boolean type of attribute. And we can also decide to check it right away, but it's not important because we're going to override it, whatever it's written here. And then we need to go into this. Let's see, what does this send out? And this one sends out this. Greater than. So we are setting an operation. It's called an attribute compare node. And it's setting an and as you can see, it's telling me that no attribute with name y is here because we changed it here. So we need to set the operation greater than, less than. We need to greater than the attribute and the value here. Okay, so the attribute is going to be our y at, just what we called it, and the value, and now it gets interesting, needs to be the number of beams. Let's just do this for now. Let's mute this. We don't need it in this. So if our y is so this is the y direction. So all these points here have y of 0. These are, or y from 0. This one has the y of 1. This one has the y of 2, 3, 4. But we need 5 beans. But anyway, it starts from 0, so the last one needs to be 4. And this attribute, what it does, it actually looks at the y attribute, this one here, y at, and it says, is it bigger than number of beams? If yes, write the result, and it writes the result under the bool attribute. So, as you can see, no attributes, number of beams, let's lower it so we can see what's going on. So, okay, so now this happens. We have a number of beams set to 1. So what does this mean? This means wherever this attribute y at is bigger than 1, it gets checked. So 3, 4, and it gets checked. 0 not. But so and then we are sending this into our point separate node. And what does this do? Let's check it out. It actually separates the geometry to 1 and 2. Geometry 1 and geometry 2. Geometry 1 is all these and our mask is set to bool attribute. So whenever this bool is checked, it doesn't show them, as you can see here. So wherever this bool is checked, the geometry gets hidden. Let's call it that. So if I change the number of beams, I show more and more of these because now nothing is hidden because the number of beams is 5 and everything here is smaller than 5. Okay. And another cool thing, why I needed this subtract, because this number of beams needs to be lowered by one number, remember, because the 0, it starts at 0 and not at 1. So we need to we need to change this value, which is, if we want 4 beams, we need to have this value to 3. Okay, and now we have 4. If we mute it, we'd have, if we mute it, we'd have 5. Oof, this was hard. Anyway, I hope you understood. And we send our points, as much points as we need. So this is it. So, and then what do? We need to place our, okay, so this is our beam. This is our points that we're going to use for our beams. But now we need to scale these points because this is not the correct position of them. So what do we do now? We scale them with the transform node. This is the transform node. It looks like this. So this is our transform node that we plugged into our combine XYZ to change, to be able to change individually all of these values. So let's delete this one and let's try to, and also it's hidden, as you can see, the rotation value, because we don't need it. And the translation, and now these are all math nodes to place these correctly. And you can see that we used our scale math node, and sorry, this is not a math node, this is the combine XYZ scale, and these are the math nodes to practically, let's show you what comes out of it. This. Now, I don't want to go over every single operation here. I've already talked too much, and you can guess that you know to place it where you need to place it. Okay. And now we have our points, and we need to place our beam. So our beam, let's go here again. Our beam, how to create this little, again, I muted something here before. Where is it? Must have muted something. Ah, here it is. Unmute. Okay, now it's okay. So this beam, what I need here, I'm gonna create, I decided to make this beam from 2 elements. First one is this element here. So this element here, sorry, let's just go into our Y view. So this is the element we're gonna need. So like this element here, that gets repeated. So I'm not so good at drawing with the mouse. Okay, so this is the element that gets repeated, just like the riser and the thread. And then another element, which is this, that has its thickness here. Okay, so this is an actual element. I needed a step help. This is actually the 1 by 1 by 1 cube split in half to have like this diagonal thing. And then I needed to scale it on this axis and on this axis and on this axis to fit inside this element right here. You guessed it, right? You understand that, right? Okay. Okay, perfect. Let's hide it again and let's go back here. And this is these are the lines. These are the lines, and then this is the vertices that go into our point scale, point instance, and point translate. So let's mute these M, And let's go here and see what happens. We have our points, and then we're gonna add our point instance, and which shows this element that I showed you, this step help, that's just placed here on these vertices. And then the point scale node that just scales them the dimension they need. Just some math nodes here and connected to the group input parameters to get them right. And that's it. As you can see now, if we change the number of beams, or if we set our height bigger, everything changes accordingly. And then the last but the most complicated thing, of course, it's this here. And these are our elements like our beam width, beam thickness. And these are just like we needed a mesh line again, mesh line, and we needed to now we use this mesh line the same way we used our groups of mesh lines. So remember these lines that were going like this, and then we removed some of them looking on this direction. And now we're gonna do the same thing with this line. So this is a mesh line. We're gonna use it. We're gonna set it to 1, 2, 3, 4 meters, and then we're gonna just delete these points the same way we deleted these points. That's the same thing we did. Same thing. And we got out, it's the same exact thing. And we got out with this. So this is, sorry, we need to delete all this, it gets in the way. So we got out with this here. These 4 points. If we lower the number, get rid of 1 point, or we have no point at all. We're 0 points. Okay, and then what we needed is to add the point instance. So this is the we used the same step instance, same step object, and we scaled it accordingly. So this is the scale we used, so number of beams and scale on the z-axis and on the width. So this is pretty self-explanatory. I already talked about these kind of things again and again. And then we went into a transform and we translated it because they needed to be placed right. If we go into our view here, without this translation, you would have it here, but we needed to have it exactly where the we need to have it exactly here. So we needed to move it on this, so we did. So we moved it exactly what we needed. Again, some math nodes. Okay, and we also needed to rotate them exactly where we needed, because If we didn't rotate them, it would be like, how do we change this? As the stair becomes more steep, we need to set this value here, and this is again a job for our math nodes and arctangent, and this is trigonometry and geometry, so you should go check that out a bit. But anyway, this is how I did it. Set the rotation by comparing the rise and the going, or true rise and going. And then we also needed the scale, and the scale is obviously the length, so how many numbers of steps, and we needed our Pythagoras to find the size of, you know, the sorry about the drawing. So, you know, the Pythagoras, this square root of this plus the square root of this, it's actually the I don't know how you call it. Anyway, check out your Pythagoras, you know that stuff. And that is practically it. So we set our beam, and then we joined all this geometry. We added a material again for all these things separately, joined them again here. And the last thing we did, the last thing we did is just moved everything. Let's just remove this. So everything was here, and I want it to be at the start of the first rise. So I just did that. And that is it. I can't believe it took me an hour. Imagine if I was going over every single node. Oh my. Anyway, sorry for this longest tutorial, and hopefully you got something out of it. But if you didn't, I'm sure you got at least this file that you can download on Gumroad, and hopefully you can use it in all your projects. I know I did this I practically did this because I needed this for my own projects, and I thought, why not show you the things I did with it. Anyway, this is probably the longest video I ever done, and I'm almost sorry. I don't know if I'm gonna be regretting posting this, because it's probably gonna do very bad. But anyway, who cares? I lost enough time making this already, so I'm posting it either way. Anyway, guys, thank you so much for watching, whoever made it until this point, and I will see you in the next one. Subscribe. As you can see, I make a lot more other videos that are not this long, and some of you seem to enjoy it. So see ya.